Hi class, today we're going to be talking about Pythagorean Theorem. So Pythagorean Theorem is used to find two missing sides. Some of you may remember this from previous classes, so we're going to do a little bit of review. We're finding two missing sides of a right triangle. Now it is very critical that we are discussing a right triangle. We cannot use Pythagorean Theorem with non-right triangles, okay? So sides A and B are going to be called the legs. And it does not matter which one is which leg. We don't distinguish leg A versus leg B. They're just the legs. And so side C is going to be always correlated with the hypotenuse. Okay. So for any right triangle, it is true that A squared plus B squared is equal to C squared. Right? So this is going to be the equation that we focus on. And so here, when we're looking at this, and we're going to be using this throughout the semester, right? Notice that it does not matter if I use the vertical line as leg A or leg B, because of the addition properties, right, of the commutative property, A squared plus B squared equals C squared. The only one we always constantly have to identify as the hypotenuse is going to be that C squared. All right, let's do a little bit of practice here. So we want to find the values of x, and we want to round each answer to the nearest 10th value. So here, notice that I have my legs already labeled, and I'm looking for the hypotenuse value. So here we're going to have 8 squared plus 13 squared equals c squared. So we're going to have 64 plus 169. It's going to equal... Oops, I'm going to change letters. It's going to equal that c squared. So then we end up with 64 plus 169. We get 233. That's going to give us the x squared. And so we're going to go ahead and take the square root of both sides here. And so we end up with x equaling the positive root of 15.3. So again, we rounded to the nearest 10th value. There's our x value. All right, we're going to take a moment to try a couple of these. Excuse me. Let's look at, you know what? I'm going to have you try 2, 3, and 4. All right, so from those three values, we should have got for number 2, we should get 34.8 as the hypotenuse here for x. Now notice for number 3 and 4, we are no longer looking for the hypotenuse, we are looking for one of the legs. And so because we are looking for one of the legs, and we've got to make sure that we set this up correctly. So it should be 7 squared plus x squared equals 9 squared. And then we're going to subtract off that 7 squared and then take the square root. And that's similarly how number 4 is going to work out. So we should have x equals 5.7 and then x equals 23.8. Let's take a look at number 5 and number 6, because notice we can be using Pythagorean theorem with shapes that are not right triangles, as long as we can partition them into right triangles. So for number 5, it might be a little bit easier to see that, you know, we're trying to find the x value here. So we can break up this equilateral triangle. And since this is an isosceles triangle, we have 24 on both sides. This notation here lets us know that these are congruent, which means they are the same length. Right, so I know I have 24 and 24 there, and then that bottom is going to be 22. Now I'm trying to find the size of the height here for this triangle, so I can see that I can break this up into a right triangle because I'm given that it's a right triangle here in the middle, right? And so then I'm going to have 24 here. I'll have x here, and notice because this is split down the middle, this should be a distance of half of this. So instead of 22, that's going to be 11. So now we can use Pythagorean theorem to continue. So I have a leg at 11. I have a leg at 24 squared. And then that's going to equal, 24 squared is my hypotenuse, sorry. I have a leg at x squared, and then that's going to equal 24 squared. All right, so then this becomes 121 plus x squared plus equals 576. So then we have x squared equals we're going to subtract 101 from 576. We get 455. And then we're going to have x equals 21.3 after we take the square root of both sides. Okay. All right, take a moment and see if you can try number 6. We're trying to find the value of x. See, how would you partition that? So the way we can go ahead and find the value of x here is because we don't have a right triangle, we have to kind of, in essence, make a right triangle. So what we're going to do is we're going to push this line here and realize that I really have two figures here. I have a right triangle, but I also have a rectangle next to it underneath it. So because of that, then I know that this, if I can partition this into two shapes, this is going to be the same value of x. So this is really the x I'm finding. So I can turn that into a triangle there. You know, so I can actually flip this over and maybe you can see it like this, right? And so here we do have to be careful. Since this is 5, then I need to take 5 off of this. So 18 minus 5, that's going to give me this 13 value here. Okay, so that's how we get that. So we're going to have, you know, our x value, 13, and then the 16 value here. And then we want to go ahead and solve that. So in doing so, we have x squared plus 13 squared equals 16 squared. All right, we go ahead and do our calculations, and we find out that x is equivalent to 9.3. Okay. All right, let's take a look at number 7. So for number 7, notice I really have two triangles here that are combined. Now, because this is a right angle, this also includes that this is a right angle. So I'm going to essentially have to deal with two different shapes. For the first shape, let's take a look at this triangle here, which is going to be a smaller triangle. And this smaller triangle has 14 here, it's 12 here, and I don't know what this is. Okay, so let's call that A. So in order to calculate this, right, I'm going to have 12 squared plus A squared equals 14 squared. So I'm going to have 144 plus A squared is equal to 196. And then we're going to go ahead and subtract 144 from 196. I get A squared is equal to 52. And so I'm going to take the square root of both sides, and we get A is equivalent to 7.2. So that's going to be this value here. So I still haven't found x, right? But now I have another triangle here. And the second triangle is going to be 12, 29, and then this question mark side that I don't know what it is, so let's call it B. So we're going to have 12 squared plus B squared equals 29 squared. So we have B squared, you know, I have 12 squared equals 144, 29 squared, which is going to give me 841. And then I'm going to subtract those two. Let me actually just write that down. 841. So then I'm going to end up with B squared. I'm going to subtract 144 from 841, and I'm going to end up with 697. And we're going to take the square root of both sides. So we get B is equivalent to 26.4. Now I found one of the legs for two different triangles, but I haven't found x. So the way I go about finding x is I need to add both of those sides together. So I'm going to have A plus B is going to really give me this x value. Okay, so I'm going to have 7.2 plus the 26.4, and that's going to give me a total of 33.6. So that's how we do that one. All right, so take a moment and try 8 and 9. All right, so hopefully you were able to partition these off into right triangles. Notice that for number 8, in order to find the value of x, we really did first need to find this initial value here because we didn't know how long that was. We can't assume that that's 25. Remember, this is the hypotenuse. So we didn't know what that y value is. So we do need to find that first. We land at 22.9, and then we plug that in to calculate this triangle here once we've got that 22.9. And we find that the x value is then 16.1. All right, for number 9, we did have to break this up. Now, do remember that these means that these are congruent. They are the same length. So that was going to give me 20. This is going to give me 20. So if this entire distance here was 40, since this distance is 26, it tells me that the distance from here to here will be 26. And so if I break off the rest of it by in half, the remaining 14, I would get 7 and 7. So now that's that total distance of 40. So now I can break that off into a triangle where I have 20, the x value, and then that bottom leg as 7, and we calculate the x value to be 18.7. All right, let's take a moment to try out some application problems quickly. So draw a picture, then solve them for the missing side. Right. So a roofer leaned a 16-foot ladder against the house. If the base of the ladder is 5 feet from the house, how high up the house does the ladder reach? So if you want to think of a ladder, so here's my ladder that is up against a house. So I know that the ladder itself is 16 feet. I know that it's 5 feet from the house. So it's going to be 5 feet here. So how high up? So my question is, well, what size is this? How high up is the ladder from the house? Okay. So here we have a good case of Pythagorean Theorem. So we're going to have 16 squared plus 5 squared is going to equal x squared. So we end up with, sorry, got a little excited there. 16 is our hypotenuse, so we're going to have 5 squared plus x squared equals 16 squared. So 5 squared is our 25 plus our x squared, and 16 squared is going to be that 256. We're going to subtract 25 from 256, so we're going to end up with x squared is equal to 231. Let's go ahead and take the square root of both sides, so we end up with x is equal to 15.2. Now, since this is a word problem, right, our answer should be in words, so we'd say that the ladder reaches 15.2 feet high against the house. Okay. All right, so go ahead and try number 11. All right, so for this one, we saw that Kurt was building a rectangular deck. If the dimensions of the deck are 10 feet by 23 feet, what is the length of the diagonal? So we should, your picture should look something like this. We have a rectangle, 23 feet, 10 feet, and then we have the diagonal, which we are looking for. And so this is really straightforward. 10 squared plus 23 squared equals x squared. We find that our value is 25.1 once we do our calculations here. And so therefore the diagonal of the deck is 21.5 feet long. All right, so hopefully this is coming together. We will do some practice in class as well. So Ashley jogged 3.4 miles east, then 5.7 miles south. How far is Ashley from her starting point? So if this is her starting point here, and she jogged east, this is going to be towards east, and then she went directly south. So east, she went 3.4 miles. It's right east here. And then she went 5.7 miles south. Now, how far away is she from her starting point? The shortest distance between 2 points is always going to be a straight line. So if we take a straight line from our starting point, we would see that we are trying to calculate this distance here. So this is going to be our x value. So both of these are my legs. So I'm going to have 3.4 squared plus 5.7 squared is going to equal x squared. So 3.4 squared, if we plug that into our calculators, we're going to get 11.56 plus 5.7 squared, we're going to get 32.49, and then that's going to equal our x squared. We're going to combine these two values for a 44.05. That's going to equal our x squared, and then let's go ahead and take the square root of both sides, and then I end up with x is equal to 6.6. So this means that in terms of our sentence, we would say that Ashley is about 6.6 miles from where she started. All right, last one for now. Let's try number 13. All right, so for this one, here's my image. We do have that wire that's connecting from the top of the telephone pole all the way to the ground here, and that distance of that wire is 31 feet. Okay, we do know that the top of the telephone pole is going to be 25 feet. So here's my image. So I'm trying to figure out, well, how far away is that base of that wire to the base of the telephone pole to where the wire is touching the ground. So I do end up with a hypotenuse of 31 feet and a leg of 25 feet. So we're going to square both of those values, and we end up with, once we take the square root, x equals 18.3. So the base of the pole is about 18.3 feet from where the wire meets the ground. All right, that's it for this section.